This is Saritha, working as Assistant Professor in the Department of ECE, Institute of Aeronautical Engineering. Today I am going to explain about working of digital camera. So in our image processing, what is the basic concept is without image we can't do anything. So for that purpose we can go for image acquisition is the first step in our image processing. After image acquisition we can go for image enhancement, restoration, morphological processing, segmentation, object recognition, representation and description, image compression and color image processing. So in that image acquisition, how we can capture the image. So how we can capture the image means with the use of sensor. With the use of sensor, the light energy can be converted into electrical energy. So here for that case we are using different types of sensors. So in that we are having different types of sensor. So sensor is nothing but with the use of sensor we can convert the light energy into electrical form. So what are the basic principle of sensor means? It converts the light energy into electrical form. Whatever the light falls on the sensor, proportional output, it gives a proportional output voltage. So here in this we are having different types of sensors are there. So first one is a single image sensor, line sensor and array sensor. In single image sensor means in this we are using only one sensor. That sensor here, this is the single sensor. Here. Light energy. The energy falls on the sensor. Whatever the energy falls on the sensor, proportional output voltage is produced. Here this is the analog output. It is voltage waveform output. Before that, here we are using filter. What is the function of filter? It removes the noise components. So with the use of filter, it removes the noise components, and here this part is nothing but sensing material. This part is sensing material and power in. With the use of this power in, we are applying the power. Here energy falls on the sensing element. The sensor receives the energy and it converted into analog output. So that is it produces the output in the form of voltage. And here number of sensors arranged in a group. Here this is one sensor. Here sensor 1, sensor 2, like that. Individual sensors arranged in a form of line. It is nothing but line of sensor. So this one is this is one sensor, this is one sensor, this is one sensor. Number of sensors arranged in a array form, arranged in a matrix form, array form. It is nothing but array of sensor. So depending on our application, we are using single sensor, a line sensor, or array of sensors. So array of sensors means whatever the light energy falls on this array of sensors, it gives a proportional output voltage. These array of sensors basically we are using in our cameras, in our digital cameras. Here image acquisition using a single sensor. The most common sensor of this type is a photodiode. Photodiode is nothing but it converts the light energy into electrical form. In that photodiode photodiode is made up of with silicon material and whose output voltage waveform is proportional to light. So output voltage waveform is proportional to light. So in this in front here this is the sensor. So between this light energy falls on this sensor. So this part is nothing but sensing area. The light energy falls on the sensor. Between this we are using filter. So with the use of filter, it removes the noise components, and here the use of a filter in front of a sensor improve the selectivity. For example, a green filter in front of a light sensor favors light in the green band of the color spectrum. So we are having different types of spectrum depending on our requirement. We are using for audio frequencies we are using 20 Hz to 20 kHz. So based on our requirement, the entire band of frequency divided into different parts. So in this we are using Here green pass filter in front of light sensor favors light in the green band of the color spectrum. As a consequence, the sensor output will be stronger for green light than for other component in the visible spectrum. So the intensity level of the green is more compared to other colors. Here, the single sensor is mounted on a lead screw that provides the motion in perpendicular direction. So observe in this image acquisition using a sensor trip. Here linear motion. Here it is we are using the linear motion strip. So this linear motion, it linearly rotates, and sensor strip means when light falls on the sensor, it linearly motion means depending on whatever the light energy falls on the sensor, it gives the proportional output. It gives the proportional output. It is the this part is nothing but imaged area. This part is nothing but imaged area, and one image line out per increment of linear motion. One image line, so the light energy falls on the sensor, again it rotates one step, and like that it capture the entire image. So whatever the energy, whatever the light energy falls on the sensor, based on that it gives output. Means it if the light falls on the sensor, it consumes a maximum light energy, means it gives the maximum output. And here in this circle, so it is nothing but a sensor ring. This is sensor ring. This part is sensor ring. It is linear motion. Sensor ring means it rotates linearly, and sensor linear motion. So this is the linear motion, and it is X-ray source. So here it is sensor ring, and here image reconstruction. After completion of this sensing, whatever the light energy falls on the sensor, and image reconstruction means it converted into light into electrical form, and in a cross-sectional image. Here cross-sectional images based on whatever the energy falls on the sensor, with the use of image reconstruction, it converts the light and it gives the electric form. So that can be in the form of analog form, with the use of sampling, quantization, and encoder, we can convert the analog image into a digital form. So with the use of sensor, it converts the light energy into electrical form. In that we are having three types: single sensor, line sensor, and array of sensor. So single sensor is nothing but we are using only one sensor, and line of sensor means single one sensors are arranged in the form of line. It is line of sensor, and number of sensors are arranged in a array form. It is array of sensor. So in our digital camera we are using array of sensor. Here in image acquisition using sensor array. Image acquisition using sensor array. Observe here the light energy falls on this sensing element. Whatever the energy, how much energy it absorbs, it gives a proportional output voltage. It is in imaging system. In this imaging system, it receives the analog input. Afterwards, this is nothing but our internal image plane. Here in this it is a projection image. So the image is in the form of continuous. When we are applying the sampling and quantization and encoder, then we are getting the image in the form of digital. So here in digital form, it is in the discrete form. So how we are representing the image means it depends on the pixels. So here each and every pixel, here this is black color, here it is white color. So depending on gray level value, how many samples are there, and depending on quantization, so how many number of bits we are using in each pixel, based on that it gives the output. And digital image scanner. So what is mean by scanner? Scanning in the name indicates whatever the text or image or any paper object we are scanning, that is reflected in our computers. So that whatever the reflected data that can be stored with the use of computers. Here, a scanner is a device. A scanner is a device that is used for producing an exact digital image replica of a photo or text or written in a paper or even an object. This digital image can be saved as a file to your computer and can be used to alter or enhance the image to apply into the web. And the most commonly used scanners in the flatbed scanner. So in these scanners we are having different types of scanners are there. Drum scanner, flatbed scanner, handheld scanner. So depending on our application, we are using the scanner. Mostly we are using in offices are flatbed scanner. So in which we are keep the object on top of the glass window. On the top of the glass window, the scanned output will be obtained in our computer. Whatever the object, whatever the text or image or anything we need to scan, we need to keep the top paper or anything on the top of the glass. Whatever it is scanned, then that is we can observe or we can obtain in our computers. So the image and text are obtained exactly through through the process of optical character recognition, OCR, optical character recognition. So this is the flatbed scanner. So in this, whatever the object we need to scan, we need to keep here in top of the glass, and after scanning it moves and vertical and horizontal, it scans the vertical and horizontal rows and columns. Whatever the resultant is obtained in our computer. This is the one type of scanner. And scanner is the historical precedence of scanners. So it scans the speed is 240 rpm, rotation per minute, and here the signal used was analog in nature. The signal used in analog in nature and were sent through telephone lines to the receptor end. In these scanners, we are having different types: drum scanners, flatbed scanner, handheld scanner, and film scanners. So, in drum scanner, so first observe the drum scanner. Here it rotates the 240 RPM, 240 RPM rotation per minute. So, whatever the object we need to scan, keep here with the rotation of this drum, it scans the entire image and whatever the output is obtained in our computer. This is the drum scanner. In drum scanner was the first ever image scanner. It was made in the year of 1957 at the US National Bureau of Standards. Here the first image was black and white with the resolution of 176 pixels. Here resolution image quality here 176 pixels. 176 pixels means the image we are representing in digital image processing. In our digital image processing, images we are representing in the form of pixels only, rows and columns. Here the combination of vertical and horizontal lines is nothing but here x and u. For example, here this part is 1 pixel, this one is 1 pixel, this is 1 pixel, this is 1 pixel, this is 1 pixel. So the image formation, generally the image is in our digital images we are representing in the form of pixels only. Pixel is nothing but picture element. Pixel is also called as picture element. Here the combining of rows and columns, here n minus 1 rows, here mn. So here the columns are n minus 1, here rows are m minus 1. So depending on the pixel is nothing but m into n, the size of the image we are representing. M into n, how many rows, how many columns, means based on that image size, we can represent m and n size. Here this scanner is mainly used in the publishing industry, and the telephony used behind the scanning is called a photo multiplier tube. With the use of photo multiplier tube, it scans the image and gives the proper output. flatbed scanners. In this flatbed scanner is the most commonly used scanning machine nowadays, and there are also desktop scanners. In this flatbed scanners, we are using charge coupled device. So in this charge coupled, how to scan the image means with the use of charge coupled device. This is the basic important term. See, charge coupled device means in that it consisting of array of sensor, array of CCD. Charge coupled device, it is charge coupled devices is formed with the use of this. In this we are placing one sensor, here we are placing one sensor, number of sensors. Number of sensor arranged in a array form, it is nothing but charge coupled device. So number of sensors are increased means maximum light energy falls on that sensor, then this charge coupled device, whatever the energy falls on this sensor, it can absorb the maximum light energy means it gives maximum output. So number of sensors are increased, it gives the maximum output voltage. So maximum light energy falls on this sensor, it gives the proportional output voltage. So in this flatbed scanners we are using charge coupled device. So this is the flatbed scanner. So the main difference between the old scanners and modern scanners is the type of image sensor used. In old scanners, we are using photo multiplier tube. And nowadays we are using charge coupled device. With the use of this charge coupled device, it gives the maximum output voltage, because in this we are using array of sensors. So number of sensors arranged in a matrix that is placed in our scanners means it maximum light energy falls on that sensor, it gives the maximum proportional output voltage. Then with the use of this charge coupled device CCD array, it gives the proper output, and image quality and resolution is also increases. So a charge coupled device sensor is used to capture the light from the scanner and then convert it into the proportional electrons. So the charge developed will be more if the intensity of light that hits on the sensor is more. So the light energy falls on the sensor. Whatever the energy, how much of light energy falls on this sensor and how much energy sensors are consumed, it gives a proportional output. So here in this flatbed sensor, so this is the original, it is a flatbed. Here lamp. So whatever the object we are keeping in our glass, then the lamp rotates from right to left and left to right. It scans the entire image and it gives the output. That output we are obtaining in our computer. Here analog to digital converter. Here charge coupled devices and lens. Handheld scanner. So in this handheld scanner, this device found popularity during the early 90s. Handheld scanners are used to scan documents by dragging the scanner across the surface of the document. So with the use of this handheld scanner is to scan the barcodes, and shopping malls we are using these scanners, and the scanning will be effective only if with a steady hand technique. So or else the image may seem distorted. So here this is the example for handheld scanners. Handheld scanner. And next one is film scanner. So this film scanner is manufactured to specially scan positive and negative photographic images. The film will be inserted in the carrier, so it will be moved to the stopper motor, and the scanning process will be done with a charge coupled device, charge coupled CCD sensor. So output is obtained in our computer. This is the film scanner. With the use of this film scanner, we can scan the positive and negative photographic images. It is specially used for positive and negative photographic scanning of positive and negative photographic images. So next one is image formation on digital cameras. How image will form on our digital cameras. So this is the internal structure of our digital camera. This is part is nothing but CCD, charge coupled device. Charge coupled device. Here this charge coupled device, it in this number of sensors arranged in a group. Here, so this it is in this we are placing one sensor, here also one sensor, here also one sensor, here also one sensor. All sensors in this boxes. It is nothing but array of sensors. So it is an image sensor, and like other sensor, it senses the value and converts them into an electric signal. In case of charge coupled device, it sends the image converted into electrical signal. So the light energy can be converted into electrical form. This charge coupled device is actually in the shape of array or rectangular grid. It is like matrix with each cell in the matrix. So it is like a matrix. Each cell in this matrix is consisting of one sensor. It contains a sensor that sends the intensity of photon. So observe here, this is the rectangular boxes. Here it is a matrix. Each and every cell has a sensing element, sensor. So sends the photons. Here sensor sends the intensity of striking photon. So whatever the light energy falls on here, it sends the intensity of striking photon. Here, one important term in our digital camera is aperture. So what is mean by aperture? So aperture is nothing but opening and closing of the camera. In front of the camera, we are having this one. If it is maximum open, if this aperture is widely open, if it is widely opened means here maximum light energy. Some maximum light energy falls on our charge coupled device and it gives the maximum output. If this aperture is narrow, if the opening of area is very narrow, means what will happen? Less amount of light energy enters, and that less amount of light falls on our sensor means it gives less output. So image quality is not clear here. Aperture is a small opening which allows the light to travel inside into the camera. Here is the picture of aperture. So this part is nothing but aperture. This part is, it is widely open. This aperture, here it is widely open. Here it is, the opening area is very small. So the blades creates a octagonal shape. Here blades creates a octagonal shape that can be opened, closed, and thus it makes sense that so the more blades will open, it is internal. It consisting of, if we are observing the front of our camera, number of blades, it is in octagonal shape, so it will more blades will open. More, if you are rotating it, more blades are open, then the hole from which light would have pass would be bigger. So maximum widely it is opened means maximum light enters into our camera. The bigger hole, the more light allowed to enter. The more light allowed to enter means maximum sensor sensing the photons, to the photons and gives the maximum output. Effect. So this effect is directly corresponds to the, so effect of the aperture directly corresponds to brightness and darkness of an image. If aperture is widely open, means maximum light energy enters into our camera, means maximum maximum light energy falls on maximum light energy falls on our sensor arrays, then maximum number of sensors sense the photons, means number of sensors sense the photons is increases, then the image, the output image is very clear. It is very clear. So if the less amount of light energy enters into our camera, what will happen? Less number of sensors are sense, then what will happen? Less amount of output is produced, then what will happen? The output image is dark only. So depending on aperture, if it is widely open, then image quality is good. If it is opening area is very less, means the image quality is somewhat poor than the widely open. So here, if the aperture opening is wide, it would allow more light to pass into the camera. More light would result is in more photons, which ultimately result in a brighter image. So observe here this image. So here it is widely open, here less open. So here less amount of light energy enters into our camera. Here maximum amount of light energy enters into our camera. This is the difference between, this is the effects of aperture is widely opened or less open. Here size. Now let's discuss in this size, aperture is denoted by a f value here, and it is inversely proportional to the opening of aperture. It is inversely proportional to the opening of aperture. Here two equations. So here the large aperture size, here small f value, here focus. So small aperture size, here great f value. If aperture size is small, whatever is the focus is increased. If aperture size is increased, then whatever f value is small. So here aperture and focus, if camera front end is maximum opened, then focus is reduced. If it is lightly opened, means focus is increased. So this is the size of the aperture and focus depends on here. Focus is increased means aperture size is decreased. Focus is decreased means aperture size is increased. And pixel. Here pixel is the smallest element of an image. So here, for example, image we are representing 256 into 256. Here the size of the image 256 means 2 power 8. Here how many gray levels here? Shades are 0 to 255. Here the size of the image is 256 means in this we are having total 256 pixels. Here 8-bit grayscale image. Means grayscale we are representing here 2 power 8. 2 power 8 means 256. Here grayscale we are representing 0 to L minus 1. Here grayscale we are representing 0 to L minus 1. 0 to L means 256 minus 1. Here how many now shades are there? 255. If we are using 8 bits in each pixel, we are having total 255 shades in that image. Here pixel is the smallest element of an image. Each pixel correspond to any one value. In an 8-bit grayscale image. The value of the pixel between 0 and 255. If we are using 8 bits means here the value of the pixel values, either this pixel is 0, in this pixel is 256 pixels. Some pixel values are 0, some pixel values are 255, means minimum gray level is 0, the maximum gray level is 255. So in this total how many shades are there? If we are using 8 bits in each pixel, we are having total 255 shades. Here the value of a pixel at any point, correspond to the intensity of the light, corresponding to the intensity of the light. Photons striking at that point. Photons striking at that point. Each pixel store a value proportional to the light intensity at that particular location. For example, observe here in our cameras. In our cameras or flatbed scanners, we are using CCD. We are using CCD. CCD is nothing but it is a rectangular form. Here in the matrix form, each cell. In this each cell, we are each cell consisting of a sensor. So whatever the light energy falls on this sensor, here suppose here the light energy falls here, maximum energy falls on this particular sensor, means it sensing the maximum photons, it gives the maximum output voltage, means here the gray level, for example 255. For example, less energy falls on this sensor, means here the sensing of photons are reduced, then what will happen? Here the gray level value is 55. Depending on light, how much light falls on the sensor, the sensor sends the light intensity. The sensor sensing the photons, means depending on light energy falls on the sensor, proportional, it gives a proportional output voltage. So the value of pixel at any point correspond to the intensity of the light, corresponds to the intensity of the light. How intensity of the light means, if maximum light energy falls on sensor, means photon striking at that point, each pixel store a value proportional to the light intensity at that particular location. So depending on light photon striking, it strikes with maximum energy, means it gives maximum gray level value. That value stores in this particular pixel only. Here it less amount photon striking at this point, means here the intensity of the light photon striking is less amount, means here the gray level value is 55. So that gray level value stores on that particular pixel only. And observe here in image formation, here this is our image. So here these boxes are nothing but arranged in a sensor. So the light energy falls on this sensor. This is one pixel. In this we are using sensor. So the light intensity or photons sense the, here a sensor sends the intensity of striking photons depending on light energy. Here it is black. Here the pixel value, here it is black, means less amount of energy falls on that particular pixel. So here the photons, sensing of photons are very less, then here it is black. Here it is white means here maximum gray level. So maximum light energy falls on that sensor, and it gives the maximum output. So like that, in this we are having number of shades are there. So this is complete white, somewhat gray. So observe here some complete black. Black means here 0 to 255 means 0 means complete black. 255 means it is white only. So between this black to white we are having 255 shades. So between these we are having 255 shades. Here complete white means here the gray level is 255. Here it is black means here the gray level is 0. Between this we are having number of shades depending on gray level. So observe here in this, for example, here the gray level value 200. So here the gray level value, for example, compared to this one somewhat white. So near to white, then here the gray level value is 220. Next here the gray level value, for example, here it is complete black means 0. Here something, here it is 55. So depending on shades and how much light energy falls on the sensor, it gives a proportional output, and whatever the energy that is stored on that particular pixel only, this is our output. So digital image is composed of a finite number of elements each of which has a particular location and value, So finite number of elements, So in digital means in discrete values here, finite number of elements, in this pixel has different value, in this pixel has different gray level values. These elements are referred as a picture element. So here pixel is also called as one important term in our image processing is pixel or PEL, picture element or pixel. So here image element, PELs and pixels. And pixel is the most widely used to denote the elements of a digital image. So digital image we are representing in the form of pixels only. Each pixel has its own gray level value. So up to here discussed about what is mean by sensor. Sensor means it converts the light energy into electrical form. And in this we are having different types of sensors. One is line sensor, and first one is single sensor, line sensor, and array of sensors. Here single sensor means we are using only single sensor. This is the sensing area, and between this sensing area we are using filter, and light energy falls on this sensor, and with the use of filter it gives the pure output, and here it gives the proportional output voltage. So we are applying the power supply to here. So this is the basic structure of the single sensor. Each and every sensor arranged in a line. It is nothing but line of sensor, and all sensors arranged in a rectangular form in a matrix. Each grid consisting of one sensor. It is nothing but array of sensor. So these are the different types of sensors. And next one is scanner. So with the use of scanner, whatever the image or text or picture we need to scan, means that is keep on our flat top of the glass. Whatever the object is there, that is obtained in our computers. So in that scanners we are having different types of scanners are there. Flatbed scanner, handheld scanner, drum scanner, and film scanner. So in the drum scanner we are using drum. The drum rotates 240 rpm, and the resolution of this one is 176 pixels. So in drum scanner it rotates 240 rotations per minute. So it with the rotation of drum it scans the entire image. In our flatbed scanner we are using charge coupled device, and it gives the highest resolution output. And handheld scanner, depending on our application we are using this handheld scanner. Just it scans the barcode scanning in shopping malls. We are using this handheld scanner. Another one is film scanner. This film scanner is basically used to scan the positive or negative charges of the scanning and films. And next one is digital camera. And in this digital camera, the basic concept of digital camera, how image formation on our digital camera means, with the use of charge coupled device. In that the basic important terms are aperture, effect, and size. If aperture, it is nothing but in octagonal form. If number of blades, inbuilt it consisting of number of blades. If number of blades are widely open, the maximum light energy enters into our camera and it gives maximum output. And if widely open means the image is in white color. If it is a less amount of light energy and the blades is less number of blades are open, then what will happen? Less amount of light energy enters into our camera, then the output is dark only compared to widely open. And effect means if it is widely open, then image quality is good. If it is less number of blades are opened, means image quality somewhat dark. And size means If aperture is widely open, then what will happen? The focus value is reduced, smaller. If aperture is open, the aperture size, opening size is very small, then focus value is increased. And here, how image is representation means whatever the light energy falls on that sensor, photons strikes the sensor, means it sensing the photons, and depending on that light energy, it gives the proportional output voltage. That output voltage, when it is in the analog form, then we are converted into digital. Whatever the gray level value is stored on that particular pixel only. Here, the in digital images, the image is represented, we are using finite number of elements. For example, in each pixel, if you are using 8 bits, means here it is 2 power 8 means 256. 256 means how many shades are there? 0 to 255. 0 to 255. Here these elements are referred to as picture element or image elements, PELs and pixels. So pixel is the term most widely used to denote the elements of a digital image. So next session, I will explain with the conversion of analog to sampling and quantization techniques. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.